Round number 7. La la la.
Why is he here?
I'm happy. Round number 7, please.
1,000.
Okay, call for each of the following metrics.
State whether it has unique solution, no solution, infinitely, or infinitely many solutions.
Solution.
Then full stop will give the set of solutions. In each case, where the system is consistent. In each case, where the system is consistent.
So this equation is 1. The coefficient of each of them -2, 6, 2, -1, 1, 1, -1, 1 times x, y, z is equal to 0, 0, 0. And this is the same thing as writing that 1 -2, 6, 2 -1, 1, 1 -1, 1 is put beside this matrix 0, 0, 0. So now we can easily reduce this matrix, which will give me what? I would say I want this to become 0 and I want this to become 0. Let's write my row 1 the way it is. The next one is to do row 2 minus 2 row 1. So row 2 minus 2 row 1 will give me 0. Row 2, that's -1. Minus 2 of this is +4, which will give me 3. Then 1 minus 2 of this is 1 minus 12, which will give me -11, then 0. And for the last row, we can say, I want this to become 0 here. So I can say row 2 row 3 minus row 1 minus row 2, sorry. So this will give me 0. This -2, 2 times this is -2, minus, so plus 1, this will give me -1, right? I'm correct? Am I correct?
Yes. Since you believe the people.
Then 2 of this is 2, minus 1 of this is 1. It's giving 0. I want this to be 1 here, and I want this to be 0. So let's work on that. I also want this to be 0. So this should be 0, this should be 0, and this should be 1. Remember that we have leading ones here, here, and here on the diagonal. That's what is pushing me to do that.
You are trying to solve the system, not trying to show that maybe the solution exists.
We are trying to show that it's consistent first.
How do you show that it's consistent?
You need to reduce it first to either Gordon elimination or just to check whether what we want to check is that the rank of this is equal to the rank of the whole of this. Okay, so this becomes hello. I want to make this one a leading one, and then the remaining ones here to become 0. I would say this minus 2 of this. So I have row 1 minus 2 row 3. It will give me 1,
0,
0, 6 minus 2, 4, 0. Then the next one, I want to make this 1. So this is just simply 1/3 row 2. So I have 0, 1, minus 11/3, 0. And then finally, I want to make this one 0. So what do?
3 row 3.
I can say 3 row 3 plus row 2. So this will give me 0. This will give me 0. 3 of this plus this is 3 minus 11 minus 8, 0. So now I need to make this. In fact, I can conclude that the system is consistent because the rank of this matrix is 3 and the rank of this other matrix is 3 and has a unique solution. See, rank of this matrix, say A, is equal to 3. The rank of A with B is still 3.
Okay.
So it's consistent. And since they are equal,
Unique solution.
that's unique solution. We want to solve it, we want to get that unique solution. That's what they asked us to do. So this is equal to, I'm going to still reduce it again. Are we together?
Yes.
So I want this to be 0, and I want this to be 0, and then I want this to be 1.
Yeah.
So how do I make that 0? I have row 1 plus half row 3. So this will give me 1, 0, 0, 0. And then I can say row 2. I want this plus this to give me 0. So what do? I have minus 11 over 3. I want to make this to be minus 11 over 3.
Minus 11 over 3.
So I can still divide by 8. So I have minus 11 over 3 times 1 over 8. That's minus 11 over 24.
So what do you want to do now?
I want this plus this times something to give me 0 for this last part.
Okay.
So I need to change this to, yes, it's still minus so that it becomes plus. So this is row 2 minus 11 over 24 row 3. This first part is 0. The next one, 1. Then I have minus 11 over 24 times minus 8. So minus will cancel minus, it becomes plus. 8 to go here 1, 8 to go here 3. I have minus 11 over 3 plus 11 over 3. This will give me 0. 0. Then I want this to become 1. So this is minus 1 over 8. Row 3. And this is 0, 0, 1, 0. So this implies that x is equal to 0. Y is equal to 0. Z is equal to 0. That means x, y, z is equal to 0, 0, 0. So this is the unique solution. That's it. So you have first of all shown that it's consistent and has unique solution, and at the same time you have shown that this is the solution.
Is it normal?
How?
Is it normal for all the solution to be 0, 0, 0?
See the
Yes,
question
it's
we're
normal.
Okay.
It's
See the
normal.
question we're given.
Number 2. So we are going to do the same thing for this. We have 1, 2, minus 1 beside 1. Then the next row, minus 2, minus 4, 3 beside 3. And then 2, 4, minus 2 beside 1. So we are going to reduce this. We have this as 1, so we are okay. The next step is to have this as 0 and this as 1. So this will give me, I'll keep my row 1 the way it is. I like it like that. Then my row 2, I want here to be 0. So I can say row 2 plus row 3. Right? So I have 0, 0, 1, 4. I want this to be 0, but I cannot really do this again. So I can say row 3 minus 2 row 1, sorry, minus 2 row 1. So this is 0, 0, 0, 1 minus 2, minus 1. I can stop here. The rank of A, this is A. The rank of A
It's 2.
is 2. The rank of
AB
A,
is 3.
B
It's 3.
is 3. The system is inconsistent. This is supposed to be greater than or rank of A is supposed to be greater than or equal to. In fact, should be exactly equal to. Rank of A should be equal to rank of A, B. But we are seeing that there is a problem. So the system is inconsistent. Hence, no solution. So for 1, we had unique solution. Here we have no solution. It remains to check the last one. Last one. So let's write that we have 1, 1, 1, 1. We are on this third one.
Yes, 2, 2, 2,
2,
2.
2, 2, 2.
I told you. 1
1 minus
minus
1. 1 minus 1.
Mhm.
So if you reduce this, what do you have? You have 1, 1, 1. Because it's a leading one, I don't need to do anything. 1. For this, I can say row 2 minus 2 row 1.
Yes.
So this will give me 0.
0, 0, 0, 0.
Row 3 minus, no, row 1 minus row 3 will be easier. So I have 0, this minus this 2, this minus this 0, right? This minus this 2, right?
Okay.
I can swap row 2, I can swap row 2 and with, are you here? I can swap row 2 with half of row 3. So I'm keeping row 1 the way it is.
And the other 4.
So I'm dividing this by 2 and I'm pushing it up here. So I have 0, 1, 0, 1. And then everything down here is 0. So we can see that
2, 2.
the rank of A is equal to 2 is equal to the rank of A beside B. So it's consistent, right?
Yes. No solution.
But we have that the dimension of this is 3. So here n is 3. Okay? 3 is more than the rank 2. So we have n minus r free variables. And that will give me what? 1 free variable. Right?
Okay.
But we are not done row reducing because this, on top of this leading one is not 0. Right?
Okay.
So if I say this row 1 minus row 2, it will give me 1, 0, 1, 0, 0, 1, 0, and then 0, 0, 0, 0. So our solution here is that we have that this implies that 1, 0, 1, 0, 1, 0, 0, 0, 0 times x, y, z is equal to 0, 1, 0. So what do we have here? We have that this time this will give me x plus z is equal to 0. This times this will give me y is equal to 1. So the free variable is on z row. So you can say let z be the free variable, say alpha. Okay? So this means that what? Here we have that x is equal to minus z, which is equal to minus alpha. Then our solution will be
Infinitely many.
x, y, z is equals to minus alpha, y is 1, and then alpha. So we have infinitely many solutions.
So we're not transferred.
So here we've seen that it has it's consistent and has infinitely many solutions. I believe you now. But we have to prove it, we have to show it. Alright, before we wrap up this video, it was observed that we have another method of solving. We could use the Cramer's method of solving, that's by finding the determinant of the first matrix, second, third, and fourth matrix, and then checking whether the system is consistent or is inconsistent. If it is consistent, we can also check whether it has infinitely many solutions or unique solutions. You can try that method if you have an idea of what it is. Thank you for watching. Please subscribe to the channel. See you next time. Bye.